Okay, so let's start with an example on sine and cosine series. Okay, so let f be the following function from 0 to pi into r, be the function defined by f of x equals x. Okay, let's find it. Sine and cosine Fourier series. All right. So solution for the sine series, sine Fourier series. We have to take all the extension of f and then find its sine series. Now our function is this, right? Just this one from 0 to pi, and to obtain its sine series, we have to extend this to, so this will be my L value to minus LL, so that it's an odd function. Well, here it is x. X is already an odd function, so I just extend it as x. Okay, so the extension to this interval is an odd function, odd extension of f of x is again given by this formula. Okay, so it is just f of x. Now I have to just find the sine series of this gadget. So I just need to compute bn's. What are bn's? They are 1 over L, right? 1 over L, integral from minus L to L, f bar x sine n pi x over L dx. Okay, in our case, since this is an odd function, this is odd and this is odd, therefore the product is even. Therefore, this thing is just 2 times the integral from 0 to L f bar x sine n pi x over L dx. And what is this? Well, L is just pi, so Bn is just 1 over, no, 2 over pi, 0 to pi. And then I have f bar. What is f bar? F bar and f are just x. So x times sine n pi x over L. L is just pi also. So I have this. Therefore, this is just 2 over pi integral from 0 to pi x times sine nx dx. And then we use integration by parts to compute this gadget. So this is just u, this is dv. So this is just 2 over pi times uv 0 to pi minus 0 to pi v du, right? So that is equal to, so Bn is just 2 over pi. U is, nereye yazdık onu? Şuraya yazdık. U is x. So it is x times v. This is dv. Integral of sine x is just minus 1 over n times cosine nx, 0 and pi, minus integral 0 to pi, v du. V is just that gadget, minus 1 over n. So that will be just 1 over n cosine nx. And then du is just dx. Okay, so 2 over pi. Okay, now when I plug, okay, so this is just what? Minus, when I plug 0, I will get 0, so only this term will give me something. So minus pi over n cosine n times pi. Okay, plus integral of this is just 1 over n squared sine nx, right? 0 to pi. Well, when I plug pi for x, I get sine n pi, which is 0. When I plug 0, I get 0. So this term is just 0. So only term that survives is this. So minus, okay, 2 over n. This is just minus 1 to the power n. And I have another minus 1. So minus 1 to the power n plus 1. Okay. So Bn is just this. Therefore, the sine series of f of x, which is just x, is just what? N from 1 to infinity, Bn sine n pi x over L. L is just pi, so we get just n from 1 to infinity. Bn is just 2 times minus 1 to the power n plus 1 over n. And then L is just pi, so right, this is just pi. Therefore, this is just sine nx. So the sine series of this function is just this expression here. Okay. Let me just this. What about the cosine series? Cosine Fourier series. Okay, this time we have to extend f as an even function. All right, this is our f. If you want to extend this as an even function, then you have to have this, right? So f bar is just this function. But actually, you know, in computation, we don't use this because we always convert the integral to an integral from 0 to pi. Therefore, actually, we just work with f, not f bar. Aslında buna sanki şeydi değil mi? Buna fo diyorduk. So this was fo. O the extension. So let me just correct that. This was fo, o the extension. O the extension, o the extension here. Yeah, the rest. And this is the even extension. So what is the even extension? Yeah, it is just absolute value of x. So x, if x between 0 and pi, and minus x if x between minus pi and 0. Okay, now we want cosine series of f. So for that I need an neydi bu? An 1 over L değil mi? 1 over L. Okay, 1 over L. 0 to L. Efendim? Ha, eksi L'den özür dilerim. F even x and then cosine n pi x over L dx. So here n starts from 0. Okay. Now this time this is even, right? This is even. So the product is even. Therefore, this integral is just 2 over L times 0 to L, the even extension times cosine n pi x over L dx. Okay, if even on the positive x-axis is just x, right? It is just original f actually. So this is just 2 over pi, 0 to pi, and this is x, and then cosine n pi x over L. But L is pi, so this is cancelled, so I have just this. Okay, and then we use again integration by parts. So let's say this is u as usual, this is dv. So we have 2 over pi, and then uv minus, okay, so from 0 to pi, minus integral 0 to pi, v du. Okay. Zero to pi. U is just x. Integral of this is just 1 over n times sine nx. So it is just x over n times sine nx. Right? So integral of this is just 1 over n times sine 0 to pi. 0 to pi. V is just, so du is just dx, and integral of that is just sine nx divided by n. And then I have nx, I am sorry. I have dx here. Okay. Now, this time when I plug pi for x, this will be 0. When I plug 0, it will be 0. So this term is just 0. And I need to take integral of this gadget again. Integral of sine is just minus cosine 1 over n. So another minus sign, so this will be plus 2 over, I had already one n here, another n comes from the integration, so we get pi times n squared cosine nx, and 0 to pi. Okay, so when I plug this, I get cosine, so 2 over pi times n squared, and then cosine n pi minus 1, and this is what? Okay, now if n is even, this is 0 because this is cosine 2n, 2 pi or 4 pi, it is 1, so you get 0. When n is odd, it is minus 1, another minus 1, so minus 2, minus 2, another minus 2, so minus 4 over pi times n squared when n is odd. So the cosine series of f of x, which is just x, is equal to, it was, remember, it was this, a0 over 2, and then plus n from 1 to infinity, a n cosine n pi x over L. All right. A0 is what? So when n is even, it is 0. So there is no A0. I have only these terms. And when n is even, and it is just an is minus 4 over pi n squared, and then cosine n x. Efendim? N eşittir sıfırda. Ha, integral onu bir hesaplayalım mı? A0 1 bölü A0'da 1 ile x'i çarpacağız değil mi? Ha evet, bu farklı gelecek, özür dilerim. A0'da kosinüs n eşittir 0 koyduğum için buradan x kare bölü 2 gelecek. X kare bölü 2, L kare bölü 2. Dolayısıyla L bölü 2. O da, efendim? Ha, eksi L'den L'ye kadar. O zaman 2L gelecek. Değil mi? L kare bölü 2, L kare bölü 2, evet. Dolayısıyla bu L, yani bizim durumumuzda pi. Ha, o zaman burası da pi bölü 2 art olacak. Tamam. So I have f which is x. So it is just pi over 2 plus. So here this summation is over even integers. So I can just write it this way. Let's say n is equal to 2k. So k from 1 to infinity. And instead of n, I write 2k. When I write 2k here, I get 4k squared. 4's are gone, so I have just minus sign. So let me just put minus sign outside. So I get cosine 2kx divided by pi times k squared. Okay? Tamam mı? Any questions? Okay. Burası bir de en üst katta değil. Efendim? En oda olduğunda oh, okay. Okay, so it will be just minus 4 over 2k minus 1 squared pi cosine 2k minus 1 pi. Çünkü şey even'da 0 ya. Evet. Sizi de uyuttum. Kendimi de. Ee, Yani burada yaptık zaten. Bir daha bakmaya gerek yok. Sıfıra evet ayrıca bakmak lazım. Çünkü şey şurada da dikkat edersen integration'da burada n'e bölüyorum ya, şurada n'e bölüyoruz. Burada n eşittir sıfırda bunu yapamazsın. Yani bu hesapta zaten biz n'yi sıfırdan farklı kabul ettik. O yüzden sıfır durumuna ayrıca bakmamız lazım zaten. Okey. Bunu yukarı kaldırayım mı? Evet. So now we start a new chapter, uh, heat equation. So that's a parabolic equation, right? Now let's see how the heat equation is derived, okay, from a physical situation. Suppose we have a rod of length L, okay, so a metal rod or a wire, and its length is L units. Okay, now, and we pick a point here, let's say X, and then we take a delta X increment. So this is delta X, so therefore this is X plus delta X. Okay. And UXT represent the temperature, the temperature what? At position X and time T. So at this point and at time T, the temperature of the rod is this much, UXT. Okay, at the position X and at time T. That's the temperature. Okay. So by the okay, So let me just write down the reasoning. By the principle of conservation of energy, uh, the net change of uh, heat inside the segment şunlara isimler vereyim. Şu P noktası olsun, şurası Q noktası olsun. Okay, so this is delta X, on the segment PQ is equal to the net heat flux across the boundaries and the total heat generated inside PQ. Okay. Yani şunu söylüyor. So the net change of heat inside this segment from P to Q is equal to the net flux across the boundary. So heat may go from this point to the other side, or heat may just come inside from these boundaries. So how much you measure how much heat comes in and how much heat goes out. You take the difference, and that's the total amount of heat or change of the net change of heat inside this. And plus, there might be a heat source here. For example, you may just heat this object here, okay? There might be a resistance and you may heat it. And that will also change the heat, the net change of heat inside this segment. Değil mi? Yani burayı ısıtabilirim de belli bir yerini. So there are two sources for the heat change, boundaries and plus the external heat source. Okay. All right. Now, if C is the thermal capacity of the rod, bunların ne olduğunu şimdi göreceğiz. And rho is the density of the rod. A is the cross section area of the rod, and K is the thermal conductivity of the rod, and Fxt is the external heat source then we calculate these terms as follows. Şimdi bakalım. Okay. Total amount of heat inside PQ. At time t. So that is equal to what? Integral from x to delta x, c times rho times a times, okay, u bu ne demek? Yani so we the amount of heat and the amount of the temperature of course are proportional, right? So and that proportion is given by I guess this C, okay, and this is just the density of the material. This is the cross section, and then you have this d tau. So this rho a and d tau is the mass of this object, right? So this is d tau, this is a, and rho is the cross section. So this is the volume times the density. This is the mass of this little segment, right? This is the mass. And then this is the thermal capacity. So it corresponds to what? I guess it is just so the temperature and the heat are so temperature is Celsius divided by heat. So it is no, calories divided by temperature, I guess. So the unit should be calories divided by temperature, the energy divided by temperature, and this is the temperature times the mass. So when you multiply with this C will disappear, and maybe here you have also gram, right? Mass. So this C is just a unit in this I guess ne denir buna? Yeah, in this. So the unit of C is this: calories divided by grams and then Celsius. So that when you multiply with these, you get the calories, right? Total amount of heat inside. Yani bir su miktar var. 1 litre su. Suppose you have 1 liter of su, water, and you wanna heat it up. So to increase the temperature 1 degrees, there is certain amount of calories you have to add, right? and they are proportional. So that's that constant. Okay? And C should be like this. Yani fizikçi değiliz ama buradan az çok okuyabiliriz. Ben bir kere mühendislik öğrencilerine bunu yapıyordum. Onlara da şey dedim. Hani siz bunları alasını görüyorsunuzdur falan diye. Yok hocam dediler. Onlar biz sorduğumuz zaman onları matematikçiler yapar. Biz onlarla uğraşmayız diyorlarmış. O yüzden yapıyorum yani. Bu iş matematikçilere kalmış. Tamam mı? Bu kadar fizik bileceksiniz. Sormayız ama. Okey. Niye sıfır olsun? X kare bölü 2. Ha ha. Ee, ama yok şöyle. Bu X değil ya. Şey. Absolute value of X. F bar. Evet evet. Ya bu buraya F bar koyuyoruz. F bar da şey ya. Absolute value of X. Tamam mı? Şimdi rahatladın mı? Okay. Okay. So net change of heat inside PQ. What is this? Well, this is the total amount of heat, right? This is the total amount of heat at time t. And you wanna know the change in this instantaneous change of heat. So you just take the derivative with respect to t, of course. Right? So it is just d over dt, integral from x to x plus delta x. Tau d tau bu. Değil mi? ds yazmış da kitap d tau olacak. Ta'ya göre integral alıyoruz. Yani x yönünde integral alıyoruz. Okay. All right. So what is the derivative of this? Well, you can take burada artık fizikçi gibi davrandığımız için hani öyle şeylere takılmayacağız. Direkt türevi içeri alın. Hani yok continuous'muş şeymiş. Değil mi? Fizikçiler hiç öyle şeylere takılmazlar. Okay. All right. Net flux onu 349'da yapıyor olmanız lazım. Türev ne zaman içeri girer, çıkar, çıkabilir mi? Okay. Net flux of heat across the boundaries. Bu da şu olacak. K çarpı A. Bu da conductivity. conductivity constant times the surface area. So from each square unit, how much heat can go out? Okay. Times, of course, okay. Ha, diyeceksiniz ki niye burada ux var? Tabii ki. Okey. Hadi bunu açıkla. Okey. Sıcaklığın x boyunca değişimi bu, değil mi? X yönünde ne kadar değişiyor ve ısı transferi nasıl olur? So this is just U sub x is the change of temperature with respect to the position. So and I would like to measure how much heat what is the rate of change of temperature at this point? Yes. And okay, also we measure how much the rate of change of the temperature at the other end. Yani şöyle bir x noktasında bir de x plus delta x noktasında. Ben şuradaki toplam heat flux'a bakıyorum. Yani ne kadar heat, so how much heat goes inside this. So what we do, we this shows how much okay. İlk önce bir let me first explain it in Turkish. If I can make a sensible explanation, then I'll translate. Otherwise, you don't need it. Şimdi ısı ne zaman yer değiştirir? Sıcaklık farklıysa, değil mi? Yoksa değiştirmez. O yüzden de sıcaklığın farkı da bu şeyle, değil mi? Yani noktadan noktaya fark ettiğinin ölçüsü bu. Yani arabayla giderken kadranda gördüğünüz şey nedir sizin? Sizin şeyinizin, değil mi? Pozisyonunuzun ne hızla değiştiğini söylüyor. Bu da sıcaklığın ne hızla değiştiğini söylüyor. O zaman şu ifade burada diyor ki sıcaklık şu hızla değişiyor. Bu ne demek? Şu kadar kalori işte her saniye dışarıya kaçıyor. Bu x yönünde türev aldığı için bu şeyi gösteriyor. Buradan buraya ne kadar kaçtığını gösteriyor. Bu ise buradan buraya ne kadar girdiğini söylüyor. Ben de neye bakıyorum? Bu dışarıya çıkan, bu içeriye giren, ikisinin farkı içerideki net miktar. Tamam mı? Yani şu ne kadar ısı girdiğini söylüyor, bu ne kadar ısı çıktığını söylüyor. Tabii bu hani bunu yüzey alanıyla çarpıyorum çünkü yani her bir santimetre kareden ısı girip çıkıyor. Bu da metalin ısıyı hangi geçirgenlikte yani ısının hangi şeyde ısı geçirgenliğini söylüyor bu da. Hani ne bileyim işte tahtaysa küçük, değil mi? Alüminyumsa çok büyük. Alüminyum çok hızlı geçirir metaller içinde ama tahta geçirmez. Değil mi? O yüzden elektronik şeylerde hep böyle soğutucular alüminyumdur. Ama evleri hani şeylerini işte ne bileyim izolasyonlu tahtayla vesaireyle ya da köpükle yaparsınız. Okay. So this U sub x is the measure of how much heat goes across this point. And this is the measure of how much heat goes across this point. So the difference gives us the amount of heat, net amount of heat that goes inside, right? This is the amount that goes out. This is the amount that goes in. Yeah, so the difference is just the net amount of heat. And then, of course, you multiply this by the surface area. And then this is the heat conductivity. So that's also affects, of course, how much the speed of heat that goes in and out. Okay. Heat generated due to external heat source inside PQ. And what is this? This will be just A times integral from x to x plus delta x f tau t dt. D tau, sorry. Hayır. Yani sadece heat equation'ı yazacağız. O equation nereden geliyor? Bir kere hayatınızda görün diye yapıyorum. Hı hı. So this is the internal heat source. So this means what? The amount of heat generated at the point x at time t. So I integrate along x. Therefore, I compute how much heat generated on this segment at time t. So what is this? This will be just calories per second. Okay, calories per second. Allah, hiçbir fikrim yok. Muhtemelen ama şey hani efendim? Evet, yani bence öyledir. Ee, Yani deneylerle tabii şeyi anlıyor insanlar. Hani e, bu şeylerin mesela e, işte şu sabitlerin buraya çarpım şeklinde gelmesi gerektiğini. Yani mesela so why do we have this constant here but not square? Okay, maybe one should have cube here. I don't know, but so they are by experiments they determine all these, and then they just make some they think about this and then they come up with these formulas. İyi, ara verelim.